this is a run through of what we did in the call today. Unfortunately, my recording didn't work properly, so next week, hopefully that improves. This week, you're going to just have me talking through these examples in turn and taking you through the work. So, simplifying a surd. What is a surd? A surd is a value where, when you square root it, you don't get a whole number or an exact value. You end up with a decimal that goes on and on and on. So that's going to be 8 point something horrible. Therefore, root 9 is not a surd, whereas the root 80 would be. However, looking at root 80, that's distinctly unpleasant. Now, what do we have to do in order to simplify a surd? Surds are based on squared numbers, which makes sense when you think about the fact that you are square rooting values. You should be really confident with your square numbers up to 10 times 10, but for the purposes of these questions, you'll normally get away with just doing the ones up to 49. But what you're doing is you're looking through this list for any value that is a factor of 16, and you are going of 80, and you are going for the highest factor, which is 16. We are going to have 16 times 5. Now that does not change my surd. 80 is 16 times 5. We are still square rooting. But the beautiful thing about surds is we are allowed to split them up because they're still multiplying together. Square root of 16, 4. Square root of 5. We can't do anything, so that stays as root 5. You have simplified that surd. If you had chosen to do 4 instead of 16, one of two things would have happened. You would have had to have simplified twice because you hadn't fully simplified the surd, or, and this is perhaps worse, you wouldn't have realised that you could simplify a second time. And that would mean you'd lose a mark for only half simplifying. So this is why we do our list, and we always look for the highest factor. The next core skill is adding and subtracting surds. So you've got root 2 plus root 2, 4 root 2 plus, root 2 plus 4 root 2 minus 3 root 2. Notice these are all the same surd. That's exactly what we want, because it means we can just write down our root 2 and say 1 lot of root 2 plus 4 lots, take away 3, gives you 2 root 2. If we look at the next one, we've still got root 2, but we've also got a root 3 there. And that means we can't combine them. We have to keep them separate, like your x's and y's in your algebra. So plus 7 minus 3, that gives you 4. And there's your answer. You can't simplify it any further. Multiplying surds, well, we're essentially doing the opposite of what we did here, where you had it combined in one root and you split it up. Here, we have them split up, but we combine them. So 12 times 8, 96. As this is a secondary recording, I am very glad that I'm able to get the correct answer that time. If you're in the call, you might have noticed I said 84 by accident. Okay. However, surds, like fractions, you must simplify. So we look down this list for any value that fits into 96. You've got 1, 4, 16. 16 times 6, which you split, and you square root the 16, so we get 4 root 6. Lastly, rationalising a denominator. Now, this is a relatively complicated example because you have a surd on the top and you have a surd on the bottom. Drawing your attention to how fractions work. You can have a half, which is equal to 2 quarters, which is the same as 3/6, which is the same as 4/8. Normally what happens is we are going this way and we are simplifying our fractions. However, it is absolutely okay if we want to go the other way and we multiply our fractions. Okay? They're still going to be the same amount, we're just writing it slightly differently. Now the aim here to rationalise the denominator is to get rid of that root 6 on the bottom. And the way we do that is multiplying by root 6, multiplying by root 6. The effect is that essentially the root disappears on the bottom and you have 4 root 12 over 6. Because you're multiplying root 2 by root 6, you just combine it under the same root. You have choices. You can either simplify the fraction or you can simplify the surd, and it is entirely your choice. I would go for the fraction first in this case, but I'll get the same answer either way. Simplifying the surd, while we do our list, 1, 4, 9, 16, it can only be 1 and 4. So 4 fits in, we're going to have root 4, root 3, all over 3. Square root of 4, 2, notice that they are all multiplying together, okay? The reason that is important is because you need to know that when you square root it, it's getting multiplied by whatever is already at the front there. So those are your core skills. You're simplifying, you're adding and subtracting, you're multiplying, and you're rationalising the denominator. This is how they can come up in exam questions. Now, if I was you, I would pause the video and I would have a look at doing these questions by yourself with the hint that remember all you were doing is multiplying top and bottom by whatever that surd is. So root 8, root 8. Assuming you've taken the time to do these yourself, we've got root 8 times root 8. So we're going to have 4 root 8 over 8 because these root signs disappear on the bottom. Simplifying. Well, we can divide top and bottom by 4. This does not affect the surd. The surd stays the same all the time. And then we simplify the surd. It can only be 4. So we have root 4 root 2 over 2. 2 root 2 over 2. And at this point in the call, we were pretty confident we had the answer, but we then had to think, actually, always in its simplest form. And we absolutely had to cancel those 2's out. So because you were multiplying by 2 and dividing by 2, it actually meant your answer was just root 2 by itself. The next one, we had times root 2 times root 2. So that was going to be root 80 over 2. And then we had to simplify 80. So we had 1, 4, 9, 16, 25, etc. However, we did cheat here because up at the top, we'd already found root 80. So we just took our answer, 4 root 5, and we used it down here. Simplify, we end up with 2 root 5. Okay, so rationalising the denominator is a really common exam question, and as you can see, there are different ways we might have chosen to do it. There is in fact another way we could have done question 6 that would have led us to the same answer. And in the same way you can multiply your surds by combining them, you can also divide your surds by combining them. So we'd have had root 40 over root 2, which gave us root 20. And then we would have simplified. And we'd have got the same answer. But you can see that there's multiple ways to do it. There's not one correct way. It's entirely your choice. Okay? This is a 3 marker. It's a relatively common 3 marker. And the reason is because it tests 2 skills. Simplifying and adding and subtracting. These questions actually give you a massive hint in them 90% of the time. And the hint is that they give you the base surd. And what I mean by that is your root 2, your root 3, your root 5, your root 7. 7 is a prime number, and it tells you it is the simplest it can be. The other 2, on the other hand, are not prime. There's a decent chance you can simplify. And what's even more likely is you can simplify them into a version of root 7. So we write our square numbers and we are looking for a value times 7 that fits into 63. 9. So we're going to have 9 times 7 plus 4 times 7. Okay? You can either do these separately over at the side, or you can do it in one big calculation, and it is entirely your choice. Personally, for speed, this is perhaps more efficient. For ensuring you get the marks by making sure it's clear and clear in both your head and on the paper, it might be easier doing them separately. But the square root of 9, 3. Square root of 4, 2. Minus the root 7 you started with. So 3 plus 2 minus 1 gives you 4 root 7. We skipped this question in the call, and I'm going to skip it just now. The thing I'm going to give you in capital letters, though, BODMAS. Okay? So you have to use BODMAS, and you have to simplify. Okay? A lot of people in my class, and I think possibly Mrs. Matheson's, had this question as homework for this week, or as work to do from home this week. And they were all utterly fantastic at getting this question started, but they were missing out on the final mark. We are to solve for x. Now remember, that means we want to move everything that isn't x to the other side. And as you all very happily told me in the call, if we add 18, root 18, we are subtracting root 18 on the other side. Opposite side, opposite operation. But we know we've got root 2 and root 18, and they don't match. So we're going to have to somehow get root 18 into a form where we can add and subtract it, because otherwise that's as simple as we can go. Root 18, what fits in? 9. So we've got root 9 times root 2 3 root 2. And we can put that back into the formula. You can see this is a point where it's easier doing the calculation over at the side and substituting it back in, or else you'd have 3 lines of working you were having to do, which could be quite extensive. 4 root 2, take away 3 root 2, you're left with just root 2. And this was where most of my class stopped. And you know what? Absolutely fine, absolutely understandable. But I'm drawing your attention back to what you're actually asked to find. You're asked to find x. We've not got x. We have root x. 2 ways of doing this. You can either say, well, by comparing, looking under the bracket, obviously x is 2, or if you like doing balancing, what you do to one side you do to the other, you could square both sides. Okay? And that would give you your x equals 2. Okay. As I said in the introduction to this call, we were going to be looking at your core skills. We were going to be having a looking at common exam questions. And we're also going to be looking at where these questions show up where surds show up in other topics. And the ones we have got to look at are function notation, vectors, and standard deviation. I'm only going to do half of the function notation with you, as that's all I did in the call. And the reason is part B really closely resembles question 18. So it would be a really good opportunity for you to give it a go yourself and see where it gets you. F of x equals 4 root x plus root 2. What is function notation? Function notation takes in a value of x and gives you f of x. So whatever value you put in, if it's f of 72, whatever value you put in, if it's x equals 72, that's you finding the function of 72, f 72. Okay, f72 therefore means that you just replace anywhere there is an x with 72. So far, so good. However, like above, this doesn't work. We've got 2 different surds. So we have to turn root 72 into a nicer to deal with surd. On the call, we had a discussion about this. Root 72 is almost a trap because your mind immediately jumps to 9, but it often misses 36. And as we said at the start, if you only get the 9, in this question that's not going to work. You're still not going to be able to add because the surds won't match. But secondly, it means even if you notice that, you'll have to do the calculation all over again. So we're going for the highest. We're going for the 36. Okay. Substitute it back in. Now remember, this is timesing. So we have 4 times 6 root 2 now. So 4 times 6, 24, root 2, and then we have plus root 2. You successfully found the value as a surd in its simplest form. Part B, I will do the start with you, just because this is a very common function notation part b. What we know is instead of f of x, we now have f of t. So all we're doing is changing where there was an x for a t. And we'll just get that out the way first. However, instead of being told the value of t that goes in, you've been told the value of f of t that comes out. So I substitute 3 root 2 instead of f of t, and I've created an equation I can solve. Now this question is nearly identical to what we did up here. And I'm going to leave you to try it yourself because it's a very valuable thing to practice. Okay. Question 4. Here we have 2 vectors and we are being asked to find the magnitude of the resultant force. Now the magnitude of the resultant force, they won't necessarily tell you what that means. They've been very nice and they've done it here, but they won't always. And what this means is add them all up. Okay. So calculate U plus V, resultant force, add them all up, express your answer as a surd in its simplest form. First step, add them all up. So U plus V equals 2 plus 7 minus 5 plus 4 minus 3 plus minus 1. Notice I've still got my vector brackets on there. If I didn't have my vector brackets, I would lose a mark. Hopefully you got the same answers and you agree with me. We've got the resultant vector. We need to find the magnitude of it. Now the way we find the magnitude is very similar to Pythagoras. So we square, we sum, and we square root. The 3 S's. Square. So we've got 9 squared plus minus 1 squared. Take away 4, minus 4, sorry, plus minus 4 squared. Now, as with Pythagoras, you don't immediately find C in C squared equals A squared plus B squared. You're finding C squared. Here, you are finding the magnitude squared. Now, I've got to sum, and that means, so I've got to square them. And then I have to sum them, and that means add them all up. And we're getting 98. So, the magnitude squared is 98. The magnitude by itself is going to be the square root of 98. But, in its simplest form, they've been really clear about that in the question. What is the simplest form of 98? Write your squared numbers. Now this one is a little bit higher than most because it's 49. So we've got the square root of 49 times the square root of 2, and we've got 7 root 2. Really commonplace for them to use surds, and the same is true for standard deviation. The reason for this is because it means they can take calculator questions and put them in the non-calculator paper. If you're preparing for a non-calculator paper, make sure you've got your surds up to scratch, because you'll end up losing straightforward marks just because your answer is not written correctly. Here we have standard deviation. Now the formula for standard deviation, is the square root of the sum of x minus x bar squared all over n minus 1. All the information you need to do the question is in there. The first thing you find is x bar. Now x bar is just a way of saying the mean. So the mean, you add them all up and you divide by the number of pieces of data and you get an answer of 4. Fab. You've got mark 1. Mark 2 is that table, and it has been a while since you've done this, I think, in general. The table also comes straight from this formula. So the first thing you find is x, and then you have x minus x bar, and then you have x minus x bar squared. You could theoretically do this all in one go, in one column, but you'd be risking a mistake, which is why it's been split up into little steps for you. So our x is just our values. Minus x bar, take away the mean. So 1 minus 4 minus 3, 4 minus 4 0, 6 minus 4 2, 3 minus 4 minus 1, 6 minus 4 is 2. And then we have to square them. What happens when you square a negative number? It is always positive. And we've done our table. Now these values in the second column, they get you your second mark. Sorry, in the third column, get you your second mark. And that seems a bit unfair because these tables can be disgusting. The only reason you need the table is so that you can get a value out of the bottom of it. And if you use that value correctly in the rest of the question, you will still get the marks. So even if you know your answer is wrong, I would say just go for it, keep going, you might pick up some marks. However, we look at our formula, we don't just want x minus x bar, we want this weird symbol. And this symbol means the sum, which is adding. So we have to add up this final column to get a sum of 18. And we use that in our formula. So the sum of all that stuff we said was 18. All over n. Now n is just your numbers of pieces of data. So we have 5 minus 1. Simplify that down. We've got 18 over 4. Now, in the call, we realised there was 2 different ways of doing this. One of them is a little bit more efficient than the other, but we're going to do both, again, just so we can see that you will get the right answer. Imagine you'd been clever and you'd decided you were going to simplify that fraction, makes it easier for the next step. Then you square root the 9 and you square root the 2 separately. You'll get 3 over root 2. Now, let's look back at how they wanted our answer. They wanted a root b all over 2. We've not got that. We've got a root 2 on the bottom, but we know if we multiply by root 2 and multiply by root 2, we will get rid of the root from the bottom. So that's if you'd been clever and you'd tried to simplify the fraction first. If you perhaps hadn't even spotted that, or you could be clever in a different way, you might choose to square root the top and square root the bottom at that stage, because you know the square root of 4 would give you the 2 that you're wanting. So we've got root 18 over 2. And now simplifying 18, we've got our squared numbers. What fits in? 9. So we've got root 9, root 2 over 2. Square root of 9, 3. Root 2, 2. The question is really, are you more confident rationalising the denominator, or would you have been more confident simplifying the third? Either way, you're getting the same answer, where A equals 3 and B equals 2. Hopefully this has been useful for you. I apologise that the recording didn't work because it would have given you more time to think through the answers as we were doing them. I will say it does mean there's a lot less awkward silence in this recording. Your core skills, you're simplifying, you're adding, subtracting, you're multiplying, and you're rationalising. They are then used throughout Surd questions. Simplifying is such a core skill, it's really unlikely you get a Surd question where you don't have to simplify. I think every single question we did here, we simplified. Rationalise the denominator, very common, 2-3 marker. If they're wanting to test you on adding, subtracting, this one will come up a lot. And if they want to start wrapping it into other topics, they could ask you to solve an equation. They could ask you to do it in function notation, in magnitude, or in standard deviation, and they can come up practically anywhere. Any questions, feel free to email me. I won't put my email address here, but you can easily access it through Teams, and I'll be happy to talk you through anything